Anybody didn't get their quiz back? Let's see. There you go.
Too many places to mess up.
Trevor?
Prime example, like that.
Let's see, Lee. Becca. Caitlin Wilson. Vince Stone. Yeah. I don't know. I'll have to look it up. Jake Meyer. Tyler Kane. Inez. Susan Patterson. Emily Monk. I like this. We'll see how long this actually lasts. Leah. Audrey. Patrick. Stephanie Harness. Sarah. Could you pass it to her, please? Jenny Dong. Sheila. Albert. Jordan. Evan. Keenan. Kelly is all the way at the end. Could you keep passing her? Rachel Peterson. Right. I guess we'll try from this other side since I'm here. Stephanie. Hannah. Rameni. Oh, two of them. Selena. Could you pass it all the way to the end? Spencer Kalata. This one too. Nathan. Jasmine. Could you, thank you. Brandon. There's two. No. Ryan Peterson. Amanda Arneson. Eric Rodriguez. Could you, Andrea Silva. Matthew Graham. Trevor. Kelsey Higgins. Aji Langotan. Jessica. Zach Bricker. Thank you. Joseph Kim. Brian Reed. You guys can help me out. Zach Alberts. Tucker Walsh. Michael Sanders. And Spencer. Okay, who did I miss? Let's see. Jenny? Caitlin? Audrey? Alright, I'm getting a little better at this. Anybody else? Okay. Questions? Yes.
Yeah,
22 on 2.2. You're trying to rhyme, huh? Yeah, I know, it's morning. Bad jokes. 22 on 2.2. What is the problem? Okay. So where did you get stuck?
I got stuck after I distributed my LCTs.
So f prime of x is the limit as h goes to 0 of 3 plus x plus h divided by 1 minus 3x minus 3h minus 3 plus x over 1 minus 3x divided by h. So far so good?
Yeah.
And then what do we do now? Multiply, divide by the least common denominator. So what do we get? 1 minus 3x times 3 plus x plus h minus 3 plus x times 1 minus 3x minus 3h all divided by h times 1 minus 3x times 1 minus 3x minus 3h. So far so good? No? Well, that's good to know.
And I think I know what I did wrong. I thought for some reason I should distribute this 3 into here, but I can't do that because of that sign.
That's a plus, not a product.
I don't know why I did that.
It's okay. So far so good?
Wait, don't you have like a fraction on the top, so therefore you need to like, because I multiplied each term, like the first part, by like 1 minus 3x.
Okay.
The top and the bottom. The second part, I multiplied by 1 minus 3x
Okay.
plus 3h, and it's just getting through crazy.
No, it's exactly this.
Okay.
See, what you would have in your situation, and I can do this here because it's easier, would be this. That would be exactly what you have.
Yeah.
Right?
Yeah.
And so the denominator just drops down. This is the two types of doing things, and they both work. You can either come up with least common denominators and then multiply and divide, by the, sorry, not multiply and divide, but then multiply by the 1 over the denominator, or you can basically do what I personally like to do in general, because it makes life a little simpler. In the sense that you just have it directly this way. They should both come up with exactly the same thing. So if you multiply the first fraction by 1 minus 3x and divide by 1 minus 3x, and multiply the second fraction by 1 minus 3x minus 3h, divide by the same quantity, and when you combine them, you should end up with exactly the same thing. The only difference is this would be your numerator, and you would have h as a denominator, which again just basically becomes this. Does everybody understand this? Yeah? No? Why I didn't get there yet?
Yeah, it's just I wasn't okay with that.
We're just stuck here so far. Move on then?
Yes.
Okay, so then this is the limit as h goes to 0 of. Now we have to distribute all this fun stuff. So I will have 3 minus 9x plus x minus 3x squared plus h minus 3xh. And now we can either multiply the two parentheses and then distribute the minus, or I can just do both of them in the same time. I'm going to do both of them in the same time because it's just easier to work with. Or am I going to confuse you if I do both of them in the same time? Okay, so then I have minus 3 minus x plus 9x plus 3x squared plus 9h plus 3xh, all divided by h times 1 minus 3x times 1 minus 3x minus 3h. So now let the crossing begin. 3 minus 3 minus 9x plus 9x plus x minus x, and then minus 3xh plus 3xh, and minus 3x squared plus 3x squared. So then all of this ends up just being the limit as h goes to 0 of 10h over h times 1 minus 3x 1 minus 3x minus 3h. The h is crossed out, and if you put in 0 for h, you end up with 10 over 1 minus 3x quantity squared.
Yeah.
Where did the 10 come from?
Yeah.
Well, I have an h and I have 9 h's.
There. Okay. I didn't see that.
Does this make sense?
Yeah.
Yes.
On number 20, I ended up getting a 0 in the numerator. It's not
That should be your answer.
How can you show that? So you have like the h plus square root of x plus h plus square root of x. You cross out.
Well, there's two ways you can do this. You can either do it all together, or you can actually separate it into two limits.
Separate it into two terms so then you can
You can solve the derivative. So if you look at it, you have x plus the square root of x, and I can take separately the derivative of x, and I can take separately the derivative of square root of x, which is why I have it written in this form. Otherwise, probably, if you solved it all together, you probably ended up with 2 times the square root of x plus 1 over 2 times the square root of x, or something along those lines, as an actual solution. So let me see, where you get stuck?
I got stuck here. So it's like, what? How do you? Because you can't cross that out.
Well, yeah. See, this is where you separate it into two parts. That's the best way to deal with it. So when you have the limit as h goes to 0 of h plus the square root of x plus h minus the square root of x over h, the best way to look at this is to say this is h over h plus square root of x plus h minus the square root of x over h. And this first part is just 1. And then the other part, you actually multiply and divide by the conjugate, and it should work out. Yes?
Shouldn't that first x be h?
Sorry?
I said, shouldn't that first x be x plus h?
Yeah, I'm skipping a step. This is x plus h plus the square root of x plus h minus x minus the square root of x. So basically the x's are just crossed out. Any other questions?
What are we supposed to do?
24? 34? As it turns out, it only works in one way. C is the function, D is f prime, B is f double prime, and A is f triple prime. As it turns out, A is a quadratic, B is a cubic, C is a quartic, and D is a... Did I say it right? No. I said it... Okay, the way they are is A, B, C, D is just actually function, first derivative, second derivative... sorry, the other way around. Third derivative, second derivative, first derivative function. The same order. Just in reverse. Yes?
On number 20, I really did not know what to do with that. I had to prime G prime of 0, and I thought I could just pick a point, so I chose X to be 1, and then I did the change Y2 minus Y1.
Why would you pick a point?
Well, I thought I could do that.
You already have the point. 0 and 1.
Yeah, I know, but what's the D prime? Yeah, that's what I was saying. The D prime, I couldn't figure out the D prime.
Why? What is the... No. I mean, I'm not being... what is... The function is... Well, okay, I labeled f of x, but it doesn't matter. Minus x cubed plus 1, right? And you're asked to find f prime of 0. Well, if you go back to the previous section, right, because this is actually from 2.1, right?
Yes.
If you go back to that, that just says that you take the limit as h goes to 0 of f of 0 plus h minus f of 0 divided by h. Strictly by the definition. That's why I was asking why not, because it's just applying the definition. There's nothing really different than in the past. All you have to do is just apply the definition. And so, now 0 plus h is just h, so it's just actually f of h minus f of 0 over h. Yes?
So on 22, the one you did, the way you set it up, can you do the same thing on level 6? Like, can you just show me how you do it?
On which one?
On 26 and 2.1.
20.
Because the way I'm doing it is so much more complicated than in method. You just set it up and then write it down. I believe it's the same concept. Like to just multiply the bottom part.
So f prime of a is the limit as h goes to 0 of f of a plus h minus f of a over h. Right? So it'll be the limit as h goes to 0 of x a plus h quantity squared plus 1 divided by a plus h minus 2 minus a squared plus 1 over a minus 2 divided by h.
Yeah.
And unfortunately I don't have the room right now, so here I'll say multiplied by star. And so star is going to be what? A plus h minus 2 times a minus 2 over a plus h minus 2 times a minus 2.
Okay, and then you throw the h on the bottom of that?
So then your original limit is just going to be the limit as h goes to 0 of h times a plus h minus 2 times a minus 2. And now what happens on top? You have the first fraction multiplied by your common denominator, so let's just be a plus h squared plus 1 times a minus 2 minus a squared plus 1 times a plus h minus 2. And now what you have to do is just multiply them out and simplify and everything else. The one thing about these types of problems, especially if it's like a fraction or something, when you start canceling things out, the numerator should not have any terms not involving h. If you have any term that doesn't involve h, then you probably did something wrong at some point. Does that make sense? Because otherwise you can't really cancel. Yeah, otherwise you can't really cancel the h's, and so you're going to end up with a number divided by 0, which doesn't make any sense, unless the derivative doesn't exist. Okay. So, anything else? Are you ready to turn it in?
Yep.
Alright, so why don't you move them to that side of the, I guess, what is it, to your left?
I just thought that would
Thank you.
there's a lot of secular. It's right, 2 lines of
Thank you. Oh. Alright, are you guys having fun with all these limits? Well, today we're going to learn how to get around the limits. Okay, so first things first. F of x is equal to a constant. What we would like to do is find out what f prime of x is. And the answer is 0. Why? Well, the proof is very simple. The limit as h goes to 0 of f of x plus h minus f of x over h is just the limit as h goes to 0 of c minus c over h, which ends up being 0. Right? Does everybody see that? Okay. So let's proceed to looking at f of x is equal to x. So what we're going to do for the next about 10 minutes or so, we're going to try and look at f of x equals x, then we're going to look at x squared, and I'll also show you x cubed, and based on these, we're going to try and see if we can figure out a pattern as to what the derivative might be, as a general rule. Okay, there's a way to come up with it. And if you've seen it before, then I guess bear with me. Okay, so what would f prime of x be? It's the limit as h goes to 0 of x plus h minus x over h. Right? Which equals the limit as h goes to 0 of h over h, which is the h's cross out and you end up with 1. Right? Does that make sense?
Yep.
Okay. How about f of x equals x squared? So f prime of x is the limit as h goes to 0 of x plus h quantity squared minus x squared divided by h. Right? Which equals the limit as h goes to 0 of x squared plus 2xh plus h squared minus x squared divided by h. Too fast?
No, we're good.
Okay. So now the x squared minus x squared is 0. So this is equal to the limit as h goes to 0 of. Notice I have two terms involving h. I can factor out an h. I'm left with 2x plus h divided by h. The h is crossed out. Put in 0 for h, and I end up with 2x. So I'm only going to do x cubed as well. I think your textbook goes to x to the fourth as well, but I'm guessing you'll figure out the pattern by then. So how about x cubed? The limit as h goes to 0 of x plus h quantity cubed minus x cubed over h.
Oh, take down the exponent.
So what is the the expansion of x plus h quantity cubed? X cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed all divided by h, right? H. Hey. So far so good? So now notice that again there's an h in every single term. So this is the limit as h goes to 0 of h times the quantity 3x squared plus 3xh plus h squared divided by h. The h is crossed out, put in 0 for h, and what do we end up with? 3x squared. So what have we accomplished? We noticed that the derivative of x is equal to 1. The derivative of x squared was equal to 2x. The derivative of x cubed was equal to 3x squared. Do we see a pattern? If we don't, let me make it a little more obvious. Let me write it 2x to the first, and as 1, let me put it as 1x to the 0. What do we notice? We notice something called the power rule that says the derivative of x to the n is equal to n x to the n minus 1. Is everybody noticing this? Or do you want me to do x to the fourth as well? Do you want to see the proof?
This makes life a lot easier in calculus.
Sorry?
Makes life in calculus a lot easier.
Well, yes and no. So far, this is just one particular thing that we discovered. Now, notice one of the things that I haven't done here. And if you actually read your textbook... Yeah, I know. It's such a novel concept. Anyway, let's say you actually are bored and you want to read this. Your TV broke down, your internet doesn't work, you have no magazines, it's pouring outside, you're all alone, there's no alcohol in the house, I don't know, did I miss anything? There's nothing to play with. You probably still wouldn't read the book, right? I mean, by choice. Okay. So notice one of the things, if you actually, as I said, if you read the book, or if you actually look through the section as I'm teaching this, you'll notice that when the power rule was actually defined in your textbook, it actually says that n has to be an integer. or actually positive integer, because that's actually what we showed. Okay, but as it turns out, and it can be proved, the fact that n can be any real number.
So the book's wrong.
No. What they do is they first say what happens if n is an integer, okay? So then they say, okay, fine, look at the integer. Now let's look at, for instance, f of x equals 1 over x. And what they do is they say, okay, let me apply the actual definition of the limit of the derivative, and when I actually apply the definition of the derivative, I'll end up with f prime of x is equal to minus 1 over x squared. Do you want me to show you the definition with the definition? So the idea is the following. F prime of x is equal to the limit as h goes to 0 of 1 over x plus h minus 1 over x divided by h. Right? You multiply and divide by x times x plus h. And when we distribute, we end up with the limit as h goes to 0 of x minus the quantity x plus h divided by h times x plus h. Right? So far so good? Which equals the limit as h goes to 0 of minus h divided by h times x plus h. The h's cancel out, and when you put in 0 for x, you end up for h you end up with minus 1 over x squared. Bless you. Does this make sense? Everybody sees this? Yeah? However, if I look at f of x equals 1 over x, I can write this as x to minus 1. And so f prime of x is going to be minus 1 times x to minus 1 minus 1. So it's minus 1 times x to minus 2, which means it's minus 1 over x squared. So the idea is, and this is where basically I just gave you the formula directly instead of having to write it twice. I just said for any n, even though we only showed it for integers. But as it turns out, it works for negative integers as well, right? Because this is x to minus 1. And notice that's my derivative. Also, and I'm not going to do this again because we just talked about it, f of x equals the square root of x. Do you remember what the derivative looked like? This is one of your problems in the homework, right? 1 over 2 times the square root of x. Right? Well, notice, if I look at f of x equals the square root of x, this is the same thing as saying x to 1/2. And so f prime of x is just 1/2 x to 1/2 minus 1. So it is 1/2 x to minus 1/2. So it's 1/2 times 1 over the square root of x. So it's 1 over 2 times the square root of x. And as I'm writing this, and as I'm looking at the class, and everybody looking at all of this, I realize this would probably be the optimal time to spend 5 minutes talking about laws of exponents. Laws of exponents. Yeah?
Yeah.
I have a feeling. Okay, we have the following. A to the n times a to the m is given to be a to the n plus m. a to the n over a to the m is a to the n minus m. Because 1 over a to the m, and I should have probably wrote that first, is a to the minus m. Do you remember any of these?
Yes.
Okay. Let's see. What else do I need? Should I say that a to the 0 is 1? A to the m all to the power n is equal to a to the m times n. Also, the square root of the nth root of a to the m is the same thing as the nth root of a quantity to the m power, and it is equal to a to the m over n. Okay? Let's see. Where are they? By the way, the reference pages on the back of on the front of your book will have a bunch of these. And I don't remember, there was somebody in the class who asked me about the, if you look at the arithmetic operations, second row, the second expression, it's actually written in the book, a over b all divided by c over d is a over b times d over c. Let's see. Yeah, I guess I have the other one, the other roots. I don't know, let's see. A to the n over b to the n is equal to a over b all to the quantity n. And I guess a to the n times b to the n is a times b to the power n. So, f of x equals the cube root of x squared. You tell me what f prime of x is. You can actually use paper and solve it. And then tell me what it is. Yes? That's a start? That's the function, not the derivative. Yes? Yes. So what we have to recognize, based on laws of exponents, from here, this is equivalent to saying that f of x is x to 2/3. And so applying the power rule gives me that f prime is 2/3 x2 minus 1/3. Do you understand why minus 1/3? 2/3 minus 1. Everybody understands this? Okay. One of the things that we're going to learn in this class is that we don't want negative exponents. So whenever you're asked to do something like this, the next immediate thing is to actually write it with positive exponents. So it's going to be 2 over 3 times the cube root of x. And you might think I'm a stickler for asking you to do this, but in reality, this is really going to be very helpful, because when we get to graphing functions, if I ask you what the domain of f prime is, from here you have no clue. Right? Notice if I write it in this form, you observe that x can't be 0 because it's in the denominator.
So you'd rather have a square root of the denominator than a negative exponent?
Yes. We don't rationalize denominators unless they're actually numbers. So whenever, if it's a rational function, then you just leave it like that. Okay, properties of derivatives. And I'm going to combine two of them together. I'm just going to write all of them together. The derivative of c times f of x is equal to c times the derivative of f of x. Which means if I have a constant times a function and I take the derivative, the constant doesn't affect the derivative. Notice how much we actually ended up using Leibniz notation, and we're going to use it a lot more from this point on. Right? Notice I'm not actually writing f prime. That's because I don't actually describe what f is. So it's a lot easier to do it in this fashion. And then the other property says that the derivative of f of x plus or minus g of x is the derivative of f of x plus or minus the derivative of g of x. Bless you. And you probably, the one problem that you've done that actually showed this particular behavior is the function x plus the square root of x, when I asked you for the derivative. And the answer was 1 plus 1 over 2 times the square root of x, which meant we took the derivative of x separately and then we took the derivative of square root of x separately. Okay? This enables us to actually come up with derivatives of functions that are a little more complicated and not just x to some power. So, I guess I have to come back to this. Let's look at a problem. For instance, if I look at 3 on page 104, says f of x is equal to 5x minus 1. And the question is, what is f prime of x? And the answer is 5. Is everybody seeing that? Why? Because the derivative of 5x is just 5, and the derivative of minus 1 is 0. Okay?
Did you write that down?
Sorry?
Did you write that down? Yeah, please.
d over dx of 5x minus 1 is equal to d over dx of 5x minus d over dx of 1. And so this is equal to 5 times d over dx of x minus d over dx of 1. And so it's going to equal 5 times 1 minus 0. So it's equal to 5. So this is why I said that the last two properties enable us to actually look at functions that have more than one term, because I can separate them into parts. Does that make sense? So here I actually applied both properties. Right? I applied the fact that the derivative of a difference is the difference of derivatives, and then I took the constant out because the constant doesn't affect the derivative. Okay? Alright, how about number 5? F of x equals x cubed minus 4x plus 6. You want me to still separate it into parts? Yes.
Why is a constant 0?
We show the derivative of a constant is 0. Somewhere. There it is. If your function is a constant, when you take the derivative, you end up with c minus c over h, so you end up with 0. Otherwise, another way of thinking about things I guess I don't have it here. Yeah, this is basically the best way to think about it. The derivative of a constant is 0. You can also think about it in terms graphically. It's a straight line, so it has no slope. Right? I mean, it has a slope of 0 because it's a straight line, horizontal line. Okay? Okay, so what is f prime of x? 3x squared minus 4. Yes?
Yes. Is that all the work we have to show on our homework?
Yes.
Oh wait, can we talk about the minus 4x for a second? What do we do there again?
Again, the constant doesn't matter. So it's 4 times the derivative of x. What's the derivative of x? 1, and so you have 3x cubed minus 4 times 1, so you end up with 3x squared minus 4. Okay, how about, I guess I'll have to skip the 7 and come back to it in a second. 9 on page 104. Everybody can read, right?
Just leave it like that the whole class.
All makes sense now.
Come on!
I'm gonna record that.
Apparently I have to hold my hand over here. Okay, number 9. I can't go get that. Thank you. Okay, so number 9 says f of t is equal to 1/4 times the quantity 2 to the 4th minus 8. So what is our derivative? Yes. Okay. I thought I forgot by now. All right. Nobody blink, nobody sneeze. Okay. What is the derivative? T cubed. Everybody sees it's t cubed? It is 1/4 times the derivative of whatever is in the parentheses. What is the derivative of t to the 4th? 4t cubed. What's the derivative of 8? 0. Work out the algebra, you end up with t cubed. Does that make sense?
So you don't account for that 4th in front of it at all.
Yeah, why do you think derivative that?
What did I say about properties of derivatives?
0.
What did I say about properties of derivatives? The derivative of a constant times a function is the constant times the derivative of the function. Right?
So we don't do anything to that property.
He's pulling the car right now.
Okay. Number 11. Y is equal to x to minus 2/5. Okay, this is boring. What is dy over dx? Question. What is dy over dx?
Is the derivative of y?
Y is the same thing as a function. So this is the same thing as saying f of x is equal to x to minus 2/5. So I'm asking for dy over dx means I'm asking for the derivative of x to minus 2/5. Remember, this is the Leibniz notation. Dy over dx is equivalent to saying f prime of x. Yes?
It is negative 2 over 5 and 7/5.
To negative 7/5. The power drops down and you subtract 1 from the... Yeah, I would like you to get used to writing it as negative 2 over 5 times x to 7/5. And you don't have to write it as a radical or anything like that, but at least put it in the denominator so you know it actually is in the denominator.
So there's really no difference between dy over dx versus the dv over dx?
Yeah, remember, all of those were equivalent. Whenever you see d over dx, means you're taking the derivative of whatever you're looking at. So Leibniz notation says, take the derivative of y with respect to x. Y is this quantity, so you have to take the derivative of this with respect to x. Alright, questions?
Wait, didn't you want us to write that out to...
I did, I said it doesn't matter if you write it with radicals or not. Okay, 13. V of r is equal to 4/3 pi r cubed. And so the question is, what is v prime of r? And again, it is an actual question, it's not rhetorical. 4 pi r squared. Very good. Slower? Slower, okay? It is, what is my variable? What is my constant? 4/3 is a constant. Is pi a constant?
Yes.
So 4/3 pi is a constant. And now what is the derivative of r cubed? Times 3r squared. 3 and 3 cancels out, so you end up with 4 pi r squared. Does that make sense?
Yeah.
Okay. How about 15? That should be interesting. Capital F of x is equal to quantity 1/2 x to the 5th. And so the question is, what is f prime of x?
Would a half be a constant?
Sorry?
Would a half be constant?
A half would be a constant. But you should keep in mind laws of exponents. Sorry? Nope. As I said, you have to keep in mind of laws of exponents. Yes?
Does the 1/2 x corn to the 5th also equal 1/2 to the 5th times x to the 5th?
Exactly. We have not learned how to take derivatives. This is called a composite function. It's a function of a function. And it's only going to be another two sections or so until we actually get to something called the chain rule that enables us to take derivatives of something like this. Before we get there, the only way we can actually solve this is to actually acknowledge that capital F of x is 1/2 to the 5th times x to the 5th. Now 1/2 to the 5th is an actual constant, x to the 5th is my function, so it'll just be 1/2 to the 5th times 5x to the 4th. Does that make sense? Yeah? You can write it as 5 over 32x to the 4th if you want.
Rather not.
Rather not? Okay. Let's see. How about number 19? Y equals x squared plus 4x plus 3 divided by the square root of x. So what do we do now?
Can you leave that square root of x on the bottom to the top with the negative 1/2?
But then you multiply with everything, right? So what you're actually saying is that we should write this as x squared over the square root of x plus 4x over the square root of x plus 3 over the square root of x. I just paraphrased what you said. You said move it on the top. It's the same thing as, and then you have to multiply it by each term, right? So when you distribute it, you end up with this. Yes?
The x squared plus 4x plus 3 times x to the
X to minus 1/2.
minus 1/3.
But again, the problem is we don't know what the derivative of a product of functions is. And we're going to find out next time that is not the derivative of a function times the derivative of the second function.
Why do they give us problems of stuff we haven't learned yet?
They haven't.
I thought you said we haven't.
Well, if you write it in this fashion, then this is equal to x to 3/2 plus 4x to 1/2 plus 3x to minus 1/2. Bless you. And so dy over dx is 3/2 x to 1/2 plus 2x to minus 1/2 minus 3/2 x to minus 3/2.
So we have to do that. We can't do the other one.
You have to do this. There's nothing else you can do. Otherwise, the only way you can actually solve this is with something called the quotient rule. But we haven't actually learned that. Okay. So, new stuff. You can obviously write it with positive exponents and so forth. You know, that's not really what I'm interested in at this particular juncture of time. Okay, ready for new stuff?
Yeah.
Okay. What is the limit as x goes to 0 of sine of x over x? 1. What is the limit as x goes to 0 of cosine of x minus x divided by x? Sorry, cosine of x minus 1. Unfortunately not. It's actually 0. Do you want to see why? The limit as x goes to 0 of cosine of x minus 1 divided by x. We multiply and divide by cosine of x plus 1. And so this becomes the limit as x goes to 0 of cosine squared of x minus 1 divided by x times the quantity cosine of x plus 1. But cosine squared minus 1 is nothing else but minus sine squared divided by x times cosine of x plus 1. And so this becomes the limit as x goes to 0 of sine of x over x times minus sine of x over cosine of x plus 1. And as we've learned above, the limit of sine of x over x is 1. Multiply by negative 0 over 2 if you wish, but the key idea is you end up with 0. Yeah?
Does cosine of x over x equal 1?
Nope. Cosine of x is 1. The only reason why sine of x over x goes to 1 is because it's 0 over 0. And we, you know, there's a geometrical interpretation of why that's actually 1. Now, you might ask yourselves, why are we doing this? And the answer is, If f of x is cosine of x, what is f prime of x? For those of you who took calculus in the past, apparently you remember that it's negative sine of x. Now, why is it negative sine of x? The limit, as h goes to 0, of cosine of x plus h minus cosine of x divided by h equals. So what can we do now? Do you remember what the sum of the cosine of a sum is? Cosine x, cosine h, minus sine x, sine h, minus cosine x, divided by h. Yeah? And we're going to do the following. We're going to write this as the limit, as h goes to 0, of cosine of x times cosine of h minus 1 over h, minus the limit, as h goes to 0, of sine of x sine of h over h. So far, so good? Yes? What have I done? I looked at the first term minus the third term, and I factor out a cosine of x. Right? And then I have the second term, and I just wrote it in this fashion. Now, the limits are in terms of h. X is just a number. In terms of x is a constant. Of h is a constant. So this is the same thing as saying it's cosine of x times the limit as h goes to 0 of cosine of h minus 1 over h minus sine of x times the limit as h goes to 0 of sine of h over h. Yes? What is the first limit? What is the first limit? Zero minus sine of x. What is the second limit? 1. So this is equal to minus sine of x. So what we have shown is that the derivative of cosine of x is equal to minus sine of x. I did not hear that. He said he hates proofs. The example or formula 4, I should say, on page 100 shows you the derivative of sine being equal to cosine. So if you're curious about how to show that, it's exactly the same way as I just did, only the sine and the cosines play reverse roles. Is this making sense? Yeah? As far as how we got them, not necessarily if they make sense, why that's the case. Okay. Let's see. So how about we do 23? Z is equal to a over y to the 10th plus b times cosine of y. So what we're actually asked to find is, we're asked to find the derivative. It says differentiate the function. So the function is z. What is the variable? Y. So what are we actually looking for? dz over dy. Right? So what is our derivative? How about if you write z as a times y to minus 10 plus b cosine of y? Would that look better? Now what is the derivative? Negative 10a y to minus 11 minus b times sine of y. Right? Since the derivative of cosine is minus sine. So we have minus 10a over y to the 11th minus b times sine of y. Yes?
If we can change out cosine, the cosine y by the sine y, why do you have to change it at all? If you can change it out easily enough.
What do you mean?
You could easily, just easy enough change minus b sine y back to plus b cosine y. What makes it have to be?
Well, you're actually taking the derivative. This is the derivative of the function. And think about the graphs. The graphs are actually not the same. Okay. Everybody remembers what a tangent line is? Do you know what a normal line is? Not a tangent line? Okay. Can you be more specific? In what form is it not a tangent line? Yes. It is perpendicular to the tangent line. Very good. So a normal line at a point is the exact same as a tangent line. The only difference is it's perpendicular to the tangent line through that point. Now, dig deep down in, I guess, intermediate algebra, was it? When are two lines perpendicular? The product of their slopes is -1, right? Do you remember that?
Yes.
So, that being said, if m is the slope of the tangent line, what would the slope of the normal line be? Negative 1 over m. Right? Okay, number 25. Okay, let me write it out. So, equation of tangent line at the point a and f of a. I'm going to say the following. Let m be defined to be f prime of a, just because I think it looks better that way. Then the equation of the tangent line is y minus f of a equals m times x minus a. Equation of normal line, y minus f of a equals minus 1 over m times x minus a. Okay? Alright, so now, problem 25 on page 104 says y is equal to 6 times cosine of x, and the point we're looking for is pi thirds and 3. So the goal of the problem is to find the equations of the tangent line and the normal line at that particular point. So what do we do? So we need the derivative of y. What is the derivative of y? negative 6 sine of x. And so what is m? Remember what I said. When you look at a tangent line, it is a line. The slope has to be a number. It cannot be a function. There shouldn't be any x's anywhere along it. Okay? So that being said, what we're looking at is we're looking at the derivative when x is equal to pi over 3. Remember I put this notation up on the board last time. That means you take the derivative and you plug in pi thirds for it. So this means that it's minus 6 times sine of pi over 3. Now if you do that on the test, you will lose points. What is sine of pi over 3? Because if I ask you geometrically, what is the slope, and you tell me it's minus 6 sine of pi over 3, what is that? Is it even positive? Is it negative? So what is sine of pi over 3? How much is it? Square root of 3 over 2. So it's minus 6 times the square root of 3 over 2. So m is then minus 3 root 3. So what is the equation of the tangent? Y minus 3 is equal to negative 3 square root of 3 times x minus pi over 3. Right? Yes? Okay. What is the equation of the normal? One over 3 root 3 x minus pi over 3. Yes, that would be, this is the same thing as root 3 over 6. Does this make sense? Yes?
So, how would you like the answer for negative 1 over this? Or would you like it?
This one? I would prefer that versus that, but that's not necessarily that big of a deal. I would be ecstatic if 95% of the class would give me these answers versus minus 6 cosine of x here, which I'm sure I'll get plenty of. If you write cosine of x there, of course. Again, what is the key idea? You're looking at an equation of a line. The slope is a number. It can't be a function. That means absolutely nothing. It has no geometrical interpretation. It has no algebraic interpretation. It's just, one equation that you just put together just to put it together. Does that make sense? Okay. Numbers 29 through 32 ask you to find the first and second derivative of a function. Would you know how to do that? So if I look at, do you want 29 or 31? Let's do 29. See, I was fast enough, I didn't get a chance to give you a choice because I know what you would have said. So I have x to the fourth minus 3x cubed plus 16x. So what is f prime of x? 4x cubed minus 9x squared plus 16. Very good. So now what is f double prime of x? 12x squared minus 18x plus 0. Right? Everybody sees this?
Yep, yeah. What do you call that again?
Second derivative.
Second derivative.
Okay. The only other problem that you have to do for homework that we haven't talked about yet would be problems from like 35 to 40. where, for instance, I think the one you have to do is 36. It says, for what values of x does the graph of, and it gives you a function, have a horizontal tangent? Do you know how to do that?
Wait, what?
Number 36, for what values of x does the graph of f of x equals, stuff, have a horizontal tangent? Not necessarily. It can be a minimum or maximum, or it can be actually an inflection point. Best case scenario is x cubed. X equals 0 is a horizontal tangent. So what you have to do is you have to take the derivative, and you have to figure out where that derivative is 0. Do you understand that, or not really? Well, we talked about this last time. The idea is if you have a function that, whatever the function is, if I look at this point right here, what is the slope of that tangent line? 0. So that tangent is horizontal. The slope of the tangent line is 0, which means the derivative at that point is 0. So that basically says that in order to find the points in which the tangent is horizontal, you have to basically solve the derivative for 0.
So we plug in 0.
35 on page 105. F of x equals x plus 2 times sine of x. Bless you. For what values of x does the function have horizontal tangents? So what you have to do is you have to find out what f prime of x is. And what is f prime? 1 plus 2 times cosine of x. So in order to find where the tangent is horizontal, you need to solve 1 plus 2 times cosine of x is equal to 0.
Pi over 2 and 3 pi.
You have to be careful. As in, this is equivalent to cosine of x being equal to minus 1/2. Well, you solve for cosine of x. Subtract 1 both sides, divide by 2. So for what values of x is cosine of x minus 1/2? Cosine is positive on the first quadrant. Let's try again. Cosine is positive on the first and the fourth quadrant. So let's again try again. We need to be in which quadrants? In the second or the third quadrants. So both numbers you gave me are not in the second or third. 5 pi over 3 happens to be in the fourth quadrant. So again, let's try again. 2 pi over 3 and 4 pi over 3, you say?
Pi over 3.
I gave you a warning at the beginning of the semester. Let me reiterate. You need to know trigonometric functions as far as this class is concerned. If you don't, you're going to be in serious trouble later on. So, the more we're going to work with these, the more you'll see trigonometric functions coming back more and more. Okay.